You ever look at a circle and just feel like it's got its own secret language? You know, like it's hiding all these geometric secrets right there in plain sight? Well, guess what? It is. And today, we're going to learn that language. We're going to crack the code. So let's get our detective hats on and dive right in. So this is it. This is our mystery. We've got tangents, a center point, one little angle, 26 degrees, and our target, that unknown angle BAC. Now, at first glance, it looks like a total mess, right? But I want you to think of it less like a math problem and more like a geometric crime scene. Every single line, every point, every angle, it's all a clue just waiting for us to find it. So, looking at this, where would you even begin? I mean, seriously, how could you possibly figure out that one missing angle with just the little bit of information you see here? It might seem impossible, but it's not. Not when you know the secret code. Okay, so to crack this thing open, we first need to learn the fundamental rules of the circle. We need a key to unlock it all, and our very first piece of that secret code is the super powerful and honestly beautifully simple right angle rule. This is our first, and you gotta remember this, absolutely crucial clue. So a tangent is just a straight line that kind of skims the edge of a circle, touching it at one single point. And when a radius, that's a line from the center of the circle out to that exact point, meets that tangent, boom, it always forms a perfect 90-degree angle. Every single time. No exceptions. And here's what that looks like in the wild. You see the radius coming out from the center, O, and it hits that tangent line. That little square symbol, that tells you everything you need to know. It's exactly 90 degrees. This is a dead giveaway, a clue you can trust every single time you see this setup. So how do we put this clue to work? It's easy. First, we spot the radius and the tangent, which immediately gives us our 90-degree angle. Now look what we've got, a right-angled triangle. And we all know that the angles in a triangle have to add up to 180 degrees. So the rest is just simple subtraction. 180 minus our 90 minus the 42 we were given. And that means angle X has to be 48 degrees. See? One rule and the problem is solved. Okay, our detective's toolkit is starting to look pretty good. Let's add our second major clue to the mix, the double angle rule. Now this one's a real game changer. Just pick any 2 points you want on the edge of the circle. The angle they create way back at the center is always exactly double the angle they make at any point on the outer edge, the circumference. It's like this perfect 2-for-1 deal every time. Now check this out, because this is what's really interesting. This rule can wear different disguises. On the left, you've got that classic arrowhead shape we all recognize. But on the right, it looks totally different. The key thing to remember is that the principle is exactly the same. The angle at the center, 2x, is still double the angle at the edge, x. So don't just memorize the picture. You gotta understand the principle behind it. You know, sometimes the biggest clues aren't the big, flashy theorems themselves. Sometimes it's something way simpler, hiding right inside the diagram. And when it comes to circle geometry, the ultimate hidden clue, the one that just unlocks so many problems, is the good old isosceles triangle. So why is this a secret weapon? Well, think about it. Any two radii in a circle are, by definition, the exact same length. So if you draw a triangle using 2 radii as 2 of its sides, you have automatically created an isosceles triangle. And because of that, its 2 base angles are always equal. If you find one, you get the other one completely free. It's a total game changer. Let's see this in action. Okay, so we're given that one base angle is 35 degrees. But since we've already spotted our isosceles triangle, we instantly know the other base angle is also 35. That's 70 degrees combined. A quick subtraction from 180 tells us the angle at the center is 110 degrees. Now we bring in our double angle rule. The angle at the edge, x, has to be half of that. So 110 divided by 2 is 55 degrees. And just like that, by combining 2 of our clues, we've cracked a case that looked way tougher a minute ago. Now, this secret code, it goes even deeper. We're not going to get lost in the weeds right now, but it's worth knowing that there are even more advanced clues for when lines and segments start crossing over each other. Basically, when lines start intersecting inside or outside the circle, there are these amazing formulas that let you figure out the lengths of the different pieces. They create these predictable, perfectly balanced equations every single time. These are some seriously powerful tools for the advanced geometry detective. All right, we've gathered our clues. We've learned the secret code. It is time. Let's go back to the beginning, face our original problem, and finally solve this mystery. Here we are again. It might have looked impossible before, but not anymore. Now we have our toolkit. We know the rules. So let's crack this case step by step. Okay, first move. What do we see? We see a radius, the line OC, and it's meeting a tangent, the line CD. And our very first rule tells us that angle has to be 90 degrees. That's our way in. That's the first domino. And that 90-degree angle instantly creates a right-angled triangle for us to work with. Triangle OCD. We now know two of its angles, the 90 degrees we just found and the 26 degrees they gave us at the start. This is exactly what we need to get rolling. Okay, so let's focus on that new triangle. We know all the angles have to add up to 180. So 180 minus our 90-degree angle minus the 26 degrees we were given leaves us with 64 degrees for the angle DOC. Now, here's a neat bonus clue. When two tangents come from the same outside point, like point D, they form two identical mirror image triangles. That means the angle BOD is also 64 degrees. So the total angle at the center, BOC, is just 64 plus 64, which gives us a crucial 128 degrees. And now for the final move. We have the angle at the center, BOC, which we know is 128 degrees. And we're looking for the angle at the circumference, BAC. Both of those angles come from the same 2 points, B and C. This is a job for our double angle rule. The angle at the edge is half the angle at the center. So 128 divided by 2 is 64 degrees. And there it is. The mystery is solved. Case closed. So what have we really learned here? I mean, we did more than just solve one problem. We've started to understand the circle's hidden language. The big takeaway here is that you now have a powerful detective's toolkit. You know that a radius meeting a tangent is a 90-degree giveaway. You know the center angle is double the one at the edge. You know to look for equal tangents coming from the same point. And most importantly, you know to always be on the hunt for that secret weapon, the hidden isosceles triangle. You see, these aren't just abstract rules for a math test. This is the underlying geometry, the hidden language of circles that shapes everything from the gears in a watch to the orbits of the planets. This code is literally everywhere, so the only question left is, what patterns will you see now?